All right, what up everybody? This is Mr. Stan coming at you with another physics video. This time we're talking about interpreting a position versus time graph, and this is part 2 of this series. In the first part we talked about how to find position and displacement. In this part we're going to talk about how to find distance and velocity. So talk about how to find distance. Okay, so first of all, distance does not equal displacement, or at least not always. All right, distance, remember, is how far something has gone total, and displacement is just how far it is from where it started. All right, so to find distance, we're going to find the distance for each line segment in the graph. So each time the graph bends, forms a new line, we're going to treat that separately. So here, the first line segment, you can see that the position goes from 6 meters up to 12 meters. So that's a change of 6 meters. Right. Next line segment, you see that the position starts at 12 meters and ends at 12 meters. So that's a change of 0. So this object would have gone 6 meters from the first 3 seconds, and then 0 more meters for the next 3 seconds. He was standing still. Right. And then finally, for the last segment, it goes from 12 down to 0. Now, we're not going to include negative numbers here because we're just talking about how far they walked. We don't care if they're going in the forward direction or backwards direction. So the actual distance this person walked would be 12 meters. Okay, so to find the total distance, we just add those 3 numbers together. 6 plus 0 plus 12 is equal to 18. Right, so that's how you find the distance. Just add up the individual distances for each line segment. All right, now let's talk about one of the most important applications of a position time graph, and that is finding the velocity. Right, velocity is a number that's going to tell you how fast something's going and in what direction it's going. Right, it includes both speed and direction. Right, so velocity is equal to the slope of the graph. Right, and if you remember from your math class, slope is equal to rise over run. So the rise is how much the graph goes up, and the run is how much the graph goes across. Let's start with finding the velocity here at 2 seconds. That lands, 2 seconds lands where you see that red dot, and that lands on the first line segment. So we're going to find the slope of that line, right? The slope of that line doesn't change between 0 and 3, and so the velocity doesn't change either. So if we find the slope of this line, that means anywhere between 0 and 3 seconds had that velocity. Okay, so how much does the graph go up? It goes from 6 meters up to 12 meters. So that's a rise of 6. How much does it go across? It goes from 0 seconds to 3 seconds. That's a rise of 3. Right now we just divide those numbers. That tells us the slope, and the slope tells us the velocity. Okay, so the velocity during this first 3 seconds was 2 meters per second. Okay, what was the velocity at 4 seconds? That you have a flat line. A flat line does not go up or go down. Therefore, the rise is 0. The run is 3. So to find the slope, you just take 0 divided by 3, and that, of course, gives you 0. All right, so the velocity was 0 during this time. You can notice the position never changed. So during that time, velocity was 0. Finally, what's the velocity at 8 seconds? Velocity at 8 seconds, you'd have to find the slope of the line that is there during the second number 8. And do that, we find the rise and the run. This time it goes down, so we're going to give it a negative number, right? It starts at 12 and goes to 0, so that's a change of negative 12. So if the rise is negative 12 and the run is 4, then we divide those numbers and we get a slope of negative 3, which tells us the velocity is negative 3. Okay, now what does velocity of negative 3 mean? It just means it's going 3 meters per second, but it's going the opposite direction, right? It's going backwards. In a lot of cases, we'll say that to the right is positive, to the left is negative. So you could say it was going to the right in the beginning when it had a velocity of positive 2, and now it's going backwards with a velocity of negative 3. All right, so with the velocity, with one number, you get the how fast it's going, in this case 3, and you get the direction, in this case in the negative direction. All right, to help us see what this looks like, excuse me, we have the Honorable Sir Cockroach. And he's going to move along this number line below you as the dot moves along the graph. So you see he goes forward, stops, and then goes back a little bit faster than he was going forward. All right, this has been another physics video with Mr. Stan. You all have a great day, and I'll see you next time.